We're talking about section 1.8 in your Math 3 textbook. This is matrices. Today we're just going to talk about a general overview of what a matrix is, and then how to add and subtract and multiply by a scalar. A matrice, or a matrix, excuse me, the plural is matrices. Matrix. That's plural. Matrices. No I. That's right. Matrix and matrices. They are ways of organizing data, or organizing information. 2, 3, 4, 5, 6, 7. All right. This is an example of a matrix. Okay, just like the movie, you have all those numbers at certain scenes in the movie. They were talking about a matrix. This is a way of organizing data without it taking up a lot of space. Okay? Just like Excel, you have rows which run horizontally. You also have columns which run vertically. Rows and columns. Okay, so I could say the second row, second column, and you would be able to say 5. Or I would say first row, third column. First row, third column, you would be able to say 6. Okay, you don't do that a whole lot, but rows and columns is how we, later on, when we do the inverse and the determinant, you'll have to use rows and columns. We label this as a 2 by 3 matrix. 2 by 3 is always rows times column. It is always rows times column. Think RC, RC colon, or remote control, or radio control. Okay? RC is how you're going to remember that. Matrix can be any dimension that you want. It can be a 2 by 2. It could be a 5 by 4. It could be a 6 by 7. Okay, any dimension that you want. Part of being able to do this is you have to know the dimension. Okay, what would the dimension of this be?
1 by 1.
Would that be a 1 by 3?
Yeah.
Or would it be a 3 by 1? It would be a 3 by 1. It's very important. Rows versus columns. 3 by 1. Write that down. You mess that up and say that it's a 1 by 3 and you're going to get a lot of problems wrong. Okay? Alright, everybody got this? Alright, let's move on. The first operation that we're going to do is adding and subtracting. In order to add or subtract 2, 4, 6, 8 plus 3, 5, negative 7, negative 11. In order to add or subtract, write this down. In order to add or subtract matrices, they must have equal dimensions. You cannot add a 2 by 2 to a 3 by 3. They don't have the right parts. In order to add, they have to be equal dimensions. This dimension is a 2 by 2. This dimension is a 2 by 2. What do you think your answer is going to be? The same. It's going to be a 2 by 2. Makes sense that if you add up two 2 by 2s, that your answer is going to be a 2 by 2. Okay? Now, what do you think is going to go in the first column and the first row? Well, you look at your problem. You've got 2 in the first row, first column, plus 3 in the first row, first column. Your corresponding parts are 2 plus 3. It's very simply a 5. Right? That's not hard. What's going to go here? Well, you look right here and you got 4 plus 5, which is 9. You're matching up your corresponding parts. Alright? How about right here? 6 plus negative 7 is negative 1. And then how about 8 plus negative 11? Negative 3. Okay? Is that difficult? No, not at all. The only way that they can make that difficult is by making a subtraction or putting a scalar, which we'll talk about in just a second. Joseph, do you have a question? No. Will Stewart, are you good?
Yeah.
No?
I'm good.
Okay. if I were to change this to subtraction, okay, just so I don't have to write down another example, let's do it as if it was subtraction. I'll give you a second to write it down. Nothing changes so much as the keep it, change it, flip it. When you have that -7 in there or that -11, you have to know what to do with it. I say again, on the test, I'm not going to allow you to use calculators in this section. So you have to be able to do basic arithmetic without a calculator. 2 minus 3 is how much? -1. How about 4 minus 5? -1 as well. Let me say this. Most of the time your answers are going to be integers, positive or negative integers, but they don't have to be. You can get an answer of 1/2 or an answer of 0.7, and that's no problem. But 90% of the time your answers are integers, either positive or negative integers. Most of the time you get answers that look like this. Not always, but most of the time. How about 6 minus -7? 13. You have to be very careful. Keep it, change it, flip it. How about 8 minus -11? 19. Is there anything at all hard about addition or subtraction? No. The key thing is what?
Keep it, change it, flip it.
Before you even do anything, what do you have to make sure?
They're correctly written.
That the dimensions are the same. If the dimensions are the same, you say not possible. I can't add these up. I cannot add a 2 by 2 to a 3 by 3. They don't have the right parts. It doesn't add up. Multiplication, yes, you can in certain cases. Okay? But with addition and subtraction, they have to have equal dimensions. Okay? All right, now let's talk about a scalar. Anybody know what a scalar is? S-C-A-L-A-R. A scalar. Anybody know? Something to use a clean fish with. I was waiting on somebody to say that. All right, let's try this. 4, 5, 6, 7, 8, 9. A scalar is typically a integer, right? It's a number sitting outside of the matrix there that we multiply throughout the matrix. It can be positive, it can be negative, it can be a fraction, it can be a decimal. Most of the time it's a positive or negative integer. It doesn't have to be. But very easily we simply distribute the 3 to everything inside the brackets. The number one reason people miss this problem is that they see, okay, I got 6 different multiplication steps, and they skip one just by careless error. Make sure and take your time and say 4 times 3 is 12 and cross it out. 3 times 5 is 15 and cross it out. Be very methodical when you're doing these problems. Don't miss it because you get in too much of a hurry. 3 times 6 is 18. 3 times 7 is 21. 3 times 8 is 24. 3 times 9 is 27. That takes care of all of these. So this, what dimension was this?
It's a 3 by 2.
It's a 3 by 2. 3 by 2. We had 6 different things going on there. We had 6 different things to multiply the 3 by. Multiplying a scalar is not hard at all. Okay, questions? All right, let's do a different one. When you have x's and y's in your matrix and you have an equal sign, you are now solving. Okay, it's going to say find x or y. Here's an easy example. 2x and 6, 8 and -3y is equal to, hold on, I'll get the door, 12, 6, 8, and 9. Copy that down. The directions are going to say find x and find y. Notice we have a 2 by 2 is equal to a 2 by 2. Do you think that those have to be the same dimensions in order for it to be equal?
Yes.
Yes. They have to be the same dimensions, otherwise it's not equal. Do you see how 6 equals 6 and 8 equals 8?
Yes.
So what do you think 2x equals?
12.
Right, match them up. 6 and 6 are equal, 8 and 8 are equal. That means 2x has to equal 12. 2x is equal to 12, what does x equal?
6.
Positive 6. Piece of cake. You're lining up first row, first column, and setting them equal. So, on the y, negative 3y is in second row, second column. What is that going to be equal to? Positive 9. What is y equal? Negative 3. Negative 3. Y equals negative 3. Anything hard about that? No, nothing hard about that. Can they make it harder?
Yes.
Sure they can. Sure they can. But this is the essence of solving a very basic matrix equation. Stop. Questions? Anybody have a question? All right, let's see if you can do one a little harder with a couple different steps all together. All right, what's going on in this problem? What do you think the directions are going to say? Solve. Find x and find y. Okay? We've got a bunch of different operations going on. What do we got first? Well, we got addition, right? We've got addition. We've got a 2 by 2 is equal to, or added to a 2 by 2. We got addition. Then outside, what do we have? Scalar, right? And then ultimately, all of this is equal to another 2 by 2. Okay, do this problem now at your desk. Try this problem now at your desk.